Hello everyone, this is KP the Math G, and the last time that we had the video, I want to say it's the 38th video. This is going to make the 39th video, I think. I'm pretty sure that's right, but anyway, we just started doing or introducing antiderivatives and the indefinite integral. Okay, so what we've got here, this word here, rewrites. Sometimes you think, well, I can't integrate that. Well, you may have to rewrite it before you can integrate it. So and it's important that we understand that we have to rewrite some things from time to time. It does help if we do that. Well, let's go ahead and get started on this. I want to start with this one here. Now remember, our integration is going to look like this. Okay, that's our symbol, and we might have something that looks like this. Okay. All right. And, well, I probably should. There we go. All right. And then I'm going to put down something like x to the, well, okay. I had in mind to put down, say, x to the, and I was going to put a fifth here, but there's a problem if I do that. So let's pick 9 here. Okay, we'll do it that way. Okay, there we go. That's probably even go 10. There's a reason for this, because there's an antiderivative that we haven't looked at yet, and that's the reason I want to make sure I don't run into that antiderivative just yet. It has to do with ln, and so I don't want to do that just yet, but later on we will. Okay, so that is the reason for all of this. Sometimes you run into this situation here, and you just have, it's like this. If you got a plus b plus c plus d all over e, well, that's a over e plus b over e plus c over e plus d over e. And that's a basic rule that I think sometimes students miss, and I don't know, it's just been a constant thing here with that. Let's see if this stay up there. I'm having trouble with my magnetic, there we go, eraser. My magnets don't want to stay in sometimes. I'm going to have to get some glue and glue them in. Alright, let's get to this problem then. Alright, so let's see. First of all, we have 5x to the 8 over x to the 10th plus 9x to the 6th over x to the 10th minus 10x to the 4th over x to the 10th minus 6 over x to the 10th. Okay. And there's one thing I'll leave off. Ooh, dx. I don't want to do that. Okay. Now there's another rule that says if I have 1 over a to the n, that's equal to a to the negative n. Okay. Alright. And so that's what I'm doing here. We're saying that n is a positive exponent, and it is. Alright, I'm going to bring this up. Here, 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 and here. And here's what I'm going to have. I'm going to have 5 x to the 8, x to the negative 10th power, Alright, plus 9 x to the 6th times x to the negative 10th power minus 10 x to the 4th times x to the 10 or the negative 10th power, and then minus 6, just raise this 10 up here, times x, x to the negative 10th power. Now delta x. We're going to rewrite it and probably finish the problem on the other side. Okay, just one of many rewrites that we have to do. You could probably skip this step and go straight to this step here. Let's go ahead and get this down to this, and then I'll flip the board over. Alright, we're running out of room, I know. 5x, now 8, plus negative 10 is negative 2. Alright, plus 9, 6 plus negative 10 is x to the negative 4. Okay, minus 10. Alright, negative 6. Alright, and write it where it can be plainly seen there. And then minus 6. Well, we already have that. Okay. And that's just mainly, if you can do it from there, we've got it. Let me write this down and then I'll flip the board over, because if I don't write it down, knowing me, I will forget. So let's see. Alright, so I've got 5x to the negative 2 plus 9x to the negative 4 minus 10x to the negative 6 minus 6x to the negative 10 delta x. Okay. Double checking just to make sure I got the signs correctly. And we do. Alright, that looks good. Alright, so let's flip the board over. So this way, let that. Alright, here we go. Let's go ahead and do this now. Let's rewrite what we just had. Okay, we had, let's see, this interval. Alright, it's an indefinite interval. If we had a definite interval, we'd have two numbers here, say from time 0 to time 2 seconds or something like, or 2 minutes or 2 hours. We'll look at that another day. Alright, 5x to the 8th, 5x to the negative 2. I've got to recopy my problem down again. Alright, plus 9x to the negative 4, negative 4. Alright, minus 10x to the negative 6, minus 6x to the negative 10th dx. Alright, there it is. You want to put this in parentheses. You're treating this as one unit. Put the whole thing in parentheses here. Then put your delta x on the outside, dx rather. Okay, now integrating. Remember how to integrate. Remember that you add, if you have x to the r, dr, or dx rather, dx in respect to x, then this is going to be x to the r plus 1 over r plus 1. Alright, without the symbol. Okay, and then plus c, okay, like that. Okay, like that. Now you're going to add 1 to your exponent. Okay. Alright, so let me, I think I just flipped my eraser over on the other side. Yes, I did. Alright, here we go. Alright, let's do this. I don't need that symbol. Once I I'm doing the derivative. I don't need this anymore. Don't carry that with you. Okay, so 5. Now add 1. When you add 1 to negative 2, it's not 3, it's negative 1, isn't it? Alright, so x to the negative 1 over negative 1. Okay, like that. Plus 9. 9 x to the negative 5 over, nope, see I did the wrong thing, plus 1 is, okay, right there. Whew, alright, there we go. Ooh, that's going to make that look good there. Alright, so add 1 to this one, that's going to be minus 10x to the negative 5. Alright, I don't need to have this here. Always remember to add 1 in integrating. Alright, minus 6x, add 1 to that, and that's going to be negative 9. And you put the negative 9 down here. And put a plus c right there. We can fix a lot of this stuff up. Let's leave the negative exponents where they are right now. We're just going to, I think 5 over negative 1 is negative 5. So negative 5, x to the negative 1. A lot of times students will fix both of them at the same time, and I'll show you what I'm talking about, but I want to do one thing at a time. 9 over negative 3 is negative 3, x to the negative 3. Okay. And then right here, wait a minute, what did I do here? Plus 1. I should have had a negative 5 down here, didn't I? Because if I add 1 here, plus 1, that's negative 5, and I need a negative 5 down here. Okay, just making sure I didn't see I didn't see my denominator down there. Oh my goodness. It has absolutely nothing to do with age. I think so anyway. Okay, negative over negative is a positive. 10 over 5 is 2. I think my wife was saying something funny to me. She tries to be funny, everybody, and sometimes she is, but you know what? I try to be funny, and I just flop. Okay. She is funny most of the time, though. Alright, so plus, here we go. 6 over negative 9 is 6 over 9. We can reduce that to what? 2 over 3. 2 over 3, x to the negative 9. Add that plus c on the end, otherwise you're not going to get the point. Especially if you do all this integrating and it looks really good and you don't put the c there, you don't get the point. Even though you did all this beautiful integrating. Alright, well what to do with the negative exponents? Well, there is a rule that says that a to the negative n is 1 over a to the n, positive n. Provided n is positive, and if n were negative, it would be okay too. But but we're saying n is positive in this case. Okay, now I'm going to just bring this down. So watch here. Just put it down. This is your, look at there. Put it down there where that 1 is. Alright, so it's negative 5 over x to the 1, positive 1. Minus 3. Keep the 3 in the numerator. Don't bring all of it down. Just the exponent part needs to come down. So x to the 3rd power. Plus 2, keep the 2 in the numerator. Alright, x to the positive 5. Okay. Oh, let's see. Alright, so plus 3's in the denominator. Put it down there where the 3 is. Alright, so x to the 9th power right there. And leave the positive 2 up here. can do that, right? And then plus c. And that's, now let's say in this particular problem, well, I don't know, we may be dealing with something like how fast water is going through a pipe, and this is the original equation for that, which it may not really represent water, the speed of water or the velocity of water going through a pipe. And what you do is you find out how much water is in the tub or in the tank. So this, when you take an antiderivative, you've changed it from a, what do you call it, a rate of change to how much or how far. Okay. Alright, so that's, just kind of keep those little things in mind, but for right now we're trying to learn how to rewrite a problem. And it's very important that we understand that. I want to do one more, if I may. I don't know if I'm going to have time for one more. Let's see. It looks like I'm going to have to reserve. We might have time for one more. Let's do one more. Okay. But we're going to have to make it quick. My wife and I exercise at the Y, and at the end, my wife knows some ladies, and a lady or two, and we all eat together afterwards, and we were supposed to exchange gifts, but not all the ladies are going to be able to show up, so we'll have to reserve that for another day. I got fathered into this after I married my wife, but you know, I like to eat out anyway, so that's pretty good. Turned out pretty nice. I want to do one more. Okay, so let's do this very quickly. I think this will be all right. We can work fast. Okay, I want to do an integration of the fourth root of x times x squared plus x dx. Alright, now here again, sometimes we just have to rewrite this. This could have been in the denominator, but I chose to put it up here as a multiplication problem here. Okay. Well, let's rewrite this in the first place. I like to rewrite this. This is, now remember, the exponent over the index number, x to the 1/4. And now, okay, like that. And now we can simply multiply that. That's going to be x to the 1/4 and times x squared plus x to the 1/4 times x dx. Now remember, when you have a to the n times a to the m, it's a to the n plus m. Remember that? So I can have 1/4 plus 2. Okay, and that's actually 2 1/4. And you can do that pretty quickly if you want to do it that way. Another way we do, if I've got x to the 1/4 times x squared, I can make this over 1, and I can simply I just simply multiply 4 times 2 and get 8. And 8 over, and the denominator, keep the denominator 4. 8 over 4 is 2. Y'all see that? I mean, this is basic arithmetic here. So just simply add the exponents. So this one is going to give us 9/4. X to the 9/4. Okay? 4 times 2 is 8. This is a 1 here. So let's apply that same principle. 4 times 1 is 4. So this is x to the 1/4 times x to the, I'm just rewriting 1, see? 4 over 4 is 1, so 1 plus 4 is 5. So x to the 5 over 4. Alright, dx. Quick and easy, isn't it? So, I mean, it's the idea of learning how to rewrite it. I'm sure you can go from here, but we are going to finish this together. I don't like to go somewhere and not finish. Alright, so remember now, we don't need this integration symbol anymore. We're integrating now. Here we go. Alright, 9/4, so x to the 9/4, 9/4 plus, now remember we're adding 1 to that, which is the same thing as 4/4, right? We're adding 1. So this is 9 plus 4 is 13 over 4. And you put the 13 over 4 in the denominator normally, but flip it over and you can already have your coefficient right there. And that's what you do. Is if you get 13 over 4, put it in front like that. If you don't have anything in front of that, you just, or even if you did, you just multiply 14/3 by whatever your coefficient is. Okay. So this is going to be x to the 5/4. Alright, add 1 to that, so 4/4 again. So this is 4/4. 5 plus 4 is 9, so plus 9 x to the, I need a little room here, x to the 9/4, okay, and then put the 4/9 like that, see? And then add that plus c so you can get that full point. Alright, so here it is, it's at the end here. So this is 4/13 x to the 13 over 4 plus 4/9 x to the 9/4 plus c, like that. Yeah, I believe I did everything right. You add 1 to 9/4, you get 4/4. 4 plus 9 is 13. Flip that over. You add 1 to 5/4, you get 5/4 plus 4 more fourths, that's 9/4. And flip that over and put it in front. Make life as simple as possible for you. And there it is. Okay. Alright. And that's basically what I had in mind to do. I had another problem, but we're not, actually a couple more problems, but time's not going to allow us to finish these. Okay. We go to the Y and work out about getting around time to go pretty soon. But so anyway, enough of my personal life. We're interested in what you want to learn. Don't forget, please, if you will, if you want to, press the subscribe button. I have a few subscribers, but do that, please, and make a comment too. Whether, even if you say something that's you know, that I did something incorrect, or I could have done something a better way. I don't think I did anything incorrect. As a matter of fact, I'm sure I didn't do anything incorrect. But if you saw something, please call it to my attention. That's what I want to do. I want to get better. I want to improve. I want to do better myself. And that's the example that I want to lay before you as a student, that you need to always strive to do better and to be better. And no matter whether you are a student or a teacher, professor, whoever you may be, you always strive to get better and to do better. So, I mean, if you have something you want to compliment on, give me a compliment. I like those. Who doesn't like a compliment once in a while? Yes, please make a comment if you feel like you need to make a comment. And I appreciate it. I'll take it to heart, and I'll go all out. And if I have to do this lesson again or something, and something that you showed me that's really a lot easier, then I'll certainly entertain that. Okay, that's KP the Math G signing off. You folks have a great day.